With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello student, question is asking which is colored because of DD transition. Okay, so we have some elements given here, compound given here, so we need to tell which one is colored because of the DD transition. Okay, as we know that DD transition means a shifting of electron between the lower energy d orbital to a higher energy d orbital by the absorption of energy and vice versa. Okay, so here as how transition metals are colored because of DD transition. Okay, so the reason behind this, when visible light, when the visible light it falls on the transition metal compound, right? It falls on transition metal compound, then what happen? Then the unpaired electron present in the lower energy d orbital get promoted to the high energy d orbital, right? Here the unpaired electron present in, and then they get promoted. Okay, then they get promoted to high energy d orbital. Okay, to promote the high energy d orbital, right? And this we called DD transition, and that's why some of the transition metal shows color. Okay, in this, due to the absorption of visible light, the transmitted light shows some color, okay, to the absorbed color, right? Okay, so here we see which one is colored due to the DD transition, right? So first of all, we talk about KMnO4, that is potassium permanganate. Okay, KMnO4. Okay, as we know that KMnO4, which is a colored compound. Okay, here it absorbs light in a visible range of EM spectra, right? Here it absorbs light in visible range, visible range of EM spectra, and here we have MnO4 negative. Okay, in this oxygen, which is a ligand, as a ligand, it donates its lone pair of electron to the empty d orbital of manganese, right? And due to which there is a charge transfer, and due to the charge transfer this compound show color. Okay, here MnO4 as a ligand, there is LMCT occurs, that is ligand to metal charge transfer. Okay, ligand to metal charge transfer, right? As we know that all the transition metals which are colored is not due to the DD transition but due to the charge transfer theory. They are colored because there are no unpaired electron. There is colored because of charge transfer spectrum. Okay, as color is associated with the electrons being promoted from one energy level to another, and the absorbing and the emitting the energy difference between the two labels. Thus the transfer of an electron from metal to ligand or ligand to metal results in the charge transfer, which give rise to spectra called the charge transfer spectra. Okay, so here KMnO4 is colored due to the charge transfer spectra, not due to the DD transition. Okay, so here option 1 is incorrect. Next we have K2CrO4. Okay, so if we talk about this compound here, so this compound which is yellow in color, and this yellow color is also due to the charge transfer. Okay, due to the charge transfer, as it has no unpaired electron, so oxygen will donates its electron to the empty d orbital of chromium. Okay, so here this shows the color due to the charge transfer, right, not because of dd transition. So this is also incorrect answer. Okay, next we have that is COCl3. Okay, we have COCl3, so let's see here. Okay, so here as we can see here, CO which have partially filled d orbital. It has partially filled d orbital. How? Okay, so if we see the oxidation state of cobalt, so the oxidation of cobalt for this compound, it will be, we take X. Okay, for cobalt and chlorine has -1 charge, for 3-chlorine it will be -3 is equal to 0, and we have X is equal to +3, right? So here cobalt has +3 oxidation state, and as we know the electronic configuration for the cobalt, which is argon 3d7 4s2. Okay, and in order to attain the configuration for cobalt +3, so 2 electron first remove from the s orbital and 1 electron will remove from this, so we have 3d6 electronic configuration, right? So if we fill these electron in the d orbital, so 2 3 4, so we have 6 electrons, so 1 2 3 4 5 and 6, right? Okay, so we have left 4 unpaired electron. Okay, 4 unpaired electron. Okay, so it has partially filled d orbital. It means here COCl3 compound, it is colored because of unpaired electron and because of dd transition. Okay, as dd transition occurred due to the presence of unpaired electron, so here this compound is colored due to the dd transition. So we have options here, so option 3 will be our correct answer because dd transition this is colored, and option 4 we have all of these, so this is completely incorrect because 2 options are already incorrect here. Okay, so this is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.